my KCET 2026 champions. So welcome back to Sankalp series, and I hope all of you are doing really well. And I have received a lot of comments to start Haloalkanes and Haloarenes. So after completing electrochemistry, I have directly jumped to this chapter so that I can help you all, right? So now tell me that have you ever used a painkiller, or have you ever seen a cockroach and or any ant, mosquito and sprayed some repellents on them? Or have you ever used AC and seen the AC cooling your room or not? So trust me, whether you believe or not, haloalkanes and haloarenes have a great role in all these things. Okay, so let me give you some example. If you are suffering from typhoid, okay, we take a medicine which contains chloramphenicol, and this is a compound of haloalkanes and haloarenes. Not only that, we have n number of examples. Malaria is treated with chloroquine, which is again a haloalkane and haloarene. We have goiters, okay, and for that we take thyroxine tablets, which again is a derivative of haloalkanes and haloarenes. So not only that, in our atmosphere, okay, you have heard about ozone layer depletion, and in that there is a major role of chlorofluorocarbons, or we call them CFCs. So here also we have the role of haloalkanes and haloarenes. So I can say that from life-saving drugs to deadly pollutants, meet the compounds that do both, and these compounds are called as haloalkanes and haloarenes. So let's meet them. Okay, so we are saying hello to two compounds, that is haloalkanes and haloarenes, in this chapter. So basically, what is a haloalkane? What is a haloarene? Very basic definition. So what happens? A single hydrogen of a compound, okay, when it is replaced with halogens like fluorine, chlorine, bromine, iodine, we get halogens, haloalkanes and haloarenes. And this one single change makes a massive difference in chemistry and in real life, right? So I'll show you the replacement of hydrogen atom, okay, in an aliphatic or aromatic hydrocarbon. Okay, aliphatic, you know, long chains, straight chains, and aromatic are cyclic compounds, right? By halogen atoms result in the formation of haloalkanes and haloarenes respectively. I'll give you a small example. So suppose we have this methane, okay? So if you just replace this one hydrogen with chlorine here, okay? So you can say this as a haloalkane, where a hydrogen is replaced by a halogen, right? Similarly, we have benzene, okay? If you know the structure of benzene, if I just, here we have H, right? So if I replace this H with chlorine, it becomes haloarenes, right? So these compounds where a single hydrogen is replaced with halogens are called as haloalkanes and haloarenes, okay? So moving to the next one. So in this chapter we will be studying in detail about how these haloalkanes, what are their classifications, how to name them, what is the nature of their bond, how they are prepared, what are their chemical properties and physical properties in detail, okay? So this chapter will be divided in 3 parts, part 1, part 2 and part 3, and in today's class we'll be talking about classification, nomenclature and nature of CX bond. Not only theory, we will be doing 10-15 question practice, and at the end I have some homework questions for you too, okay? So let's explore this chapter, let's decode this chapter, where the entry of a single atom, a single halogen, can change the entire game. Okay, okay, fine. So first we'll talk about classification. So generally, what do you mean by classification? Means segregation, okay? How can you separate the compounds? What are the different criterias on the basis of which we can segregate this haloalkanes or haloarenes? So basically, we have 3 criterias, okay? So what is that? First is number of halogen atoms. Based on the number of halogen atoms, we can classify them. Second, Sp3 carbon and X bond, means the carbon is Sp3 hybridized here and we have a halogen atom. Based on that, how we can classify. Third one is Sp2 carbon, and then we have a halogen attached to a Sp2 carbon. So now if I show you, for Sp3 and CX bond, we have further 3 classifications: alkyl halides, allylic halides and benzylic halides. Okay, I'll be talking about in detail, all of them, so please don't worry. And for Sp2 C-X Bond, we have vinylic halides and we have aryl halides. Okay, so these all things we will talk in detail with examples, so please don't worry at all. Each and every concept I'll explain with full detail, with full examples, so that you will be completely clarified with the concepts. Okay, so just you have to watch the video till the end. Please watch till the end, because you have a lot of question practice also, so that you will be more thorough with the concepts. Okay. So now let's talk about the first type of classification, that is number of halogen atoms. From the name itself it is very clear, number of halogen, how many halogen atoms are present in a compound. For example, here X represents the halogen atoms. Okay, so monohaloalkane means only one halogen will be present. Now let's talk about dihaloalkane. Di represents 2, so we have 2 halogens attached to the given compound. Next we have trihaloalkanes. Tri means 3, so when we have 3 halogen atoms, we will call it as trihaloalkanes. I hope this is clear. Next let's move to haloarenes. Haloarenes means benzene ring. To the benzene ring attached halogens. Okay, so if we have one X attached, then we call it haloarene, monohaloarene. When we have 2 halogens attached, we call it dihaloarene, and when we have 3 halogens attached, we call it trihaloarene. Right, this is very simple, and I hope all of you have understood this one. Okay, so this is the first criteria of classification on the basis of number of halogen atoms. Right, students, let's move to the next factor or next criteria of classification, that is Sp3 carbon and X bond. Okay, so what is Sp3 carbon? You should remember that if a carbon has 4 single bonds, okay, all the 4 carbon can always form 4 bonds. Now if all the 4 bonds of the carbon are single bond, then we call it a Sp3 hybridized carbon. Okay, so in an Sp3 hybridized carbon, what all classifications we can have? So the first one is we have primary, secondary and tertiary, and this is very important to understand. Now see, if the carbon or if the halogen to which the carbon is attached, okay, or let me just repeat, the halogen is attached to one carbon, right? That carbon is attached to how many carbons? Let me repeat it for you. This is a halogen, okay, this is attached to one, this is halogen, and this is attached to one carbon. Now this carbon is attached to how many other carbons? That will matter here. So if this carbon is attached to only one other carbon, then we call it as primary. So how can I check here? So if you see, this is the halogen, this is the carbon which is attached to halogen. Now we have to check that this carbon is attached to which or how many carbons? This carbon is directly attached to only one more carbon. Now R represents here organic group or carbon group. Okay, so this carbon which contains the halogen is attached to only one carbon, so this will be our primary carbon. So now let's talk about the secondary carbon. Now secondary carbon means what? The carbon which is containing the X group, or the X group is attached to this carbon. This carbon is attached to how many other carbon? This carbon is attached to 2 other carbons, right? Carbon containing the halogen is attached to 2 other carbons. So this will be called as secondary carbon. I hope this is clear. Now bacha log, let's move to the third one. Third one is what? Here the carbon which contains the X group, it should be attached to, very correct, 3 other carbons, right? If it is attached to 3 other carbons, then we will call it as tertiary. Okay, I hope this is clear. Let me repeat it. You have to see one carbon, the carbon which contains the X group. Okay, that carbon you have to check. If this carbon is attached to only one carbon, we will call it as primary. If this carbon is attached to 2 carbon, then we will call it as secondary. If this carbon is attached to 3 other carbon, then we will call as tertiary. Okay, I hope this is clear. Okay, now let's move to the next criteria, that is, just a minute. Yeah, so next one is your allylic halides. Now again, this is very important. Allylic halides you have to understand. See, the carbon which contains the X group, the carbon which contains the X group should be attached to a double bonded carbon. Here it is very important to understand, the X group is not attached directly to the double bonded carbon. You have a carbon, okay, double bond, next carbon is there and this carbon is having X group. Okay, you have a carbon which is attached to double bond, and now this carbon, if it contains the X group, we will call it as allylic carbon. I hope this is clear. If you have a carbon which is attached to a double bond carbon and now that carbon contains a X group or halogen group, that is called as allylic carbon. Moving to the next one, benzylic halides. This is very similar to this one, but here what happens, you need to think of a benzene ring. So you have a benzene ring, to the next one you have a carbon and that carbon contains a X group. Okay, so if a X group is present on a carbon which is attached to benzene ring, we call it as benzylic carbon. Benzylic, allylic, primary, secondary and tertiary. Okay, so this is, if you see in all this carbon which contains the X, that is your Sp3 hybridized. How? Now see, this carbon has 4 sigma bonds, so it is Sp3 hybridized. This carbon has 4 sigma bonds, so it is also Sp3. This carbon has 4 bonds, so it is also Sp3. Now if I talk about this one, if you see this carbon, it also has 4 sigma bonds, so this carbon is also Sp3. And if I talk about this particular carbon, I have a benzene ring, right? You have this carbon, then you have HH, and here we have X. So this carbon also has 4 sigma bonds, so it is also Sp3 hybridized. Okay, I hope now this is clear. Now we will move to the third classification, that is Sp2 carbon. Now Sp2 carbon means what? This carbon, what is the meaning of Sp2 carbon? This should have 3 sigma bonds. Okay, this should have 3 sigma bonds. Now if I talk about the first one, vinyl halides. In vinyl halides, if you see this carbon, I have this one C, X and this one H is there, right? So how many sigma bonds are there? It only has 3 sigma bonds. So this is a Sp2 hybridized carbon. So whenever a X or a halogen is directly attached to a double bonded carbon, I hope now you are getting the difference between allylic and vinylic. Let me show you. So this is allylic, where the carbon which contains the X group is attached to the double bonded carbon. And what is vinylic? Vinylic is where X is directly attached to double bonded carbon. This is vinylic, this is allylic. Okay. And here also we have a cyclic ring. This carbon is having double bond, it is directly attached to a halogen. So these two are example of vinylic halides. Now if I have next one, aryl halides. Aryl halides means when you have an aromatic ring and directly there the X is attached or the halogen is attached, we call it as arylic halides. Okay, so students, with this the classification part we have completed. So if you have understood till now all the classification, please give a thumbs up or just please give me in the comment section done ma'am or yes ma'am, so that I will know that all of you have understood till this, that is classification. Let me just repeat it quickly. Classification, first one is your number of carbons, like monohaloalkanes, dihaloalkanes, trihaloalkanes. The second one is Sp3 and X bond. In that case we have primary, secondary and tertiary. Then we have allylic and benzylic. In Sp2 X carbon bond, what we have? The first one is vinylic, the second one is arylic. So I hope the classification is completely clear in your picture. Just imagine like this, we have 3 types of classification, number of haloalkanes, then Sp3X and Sp2X. Okay, just quickly close your eyes and try to recall everything, and if it is able to recall, if you are able to clear all your concepts regarding this, please put a thumbs up here and let's move with the questions now based on this one. Okay. Yes, so now here's a quiz time and I want all of you to participate here, to put down your answers in the comment section and let me know that you have understood the concepts. Okay, so those students who will be answering here next video, I will be recognizing them. I'll be putting your names. I'll be wishing you all the best so you can be very popular among your friends. So please put down your comments in the comment section. First question, which of the following is a secondary halide? Okay, so I will draw a structure for you. These names will be more clarified when we will be doing nomenclature. So I'll be doing all the options for you. Okay, isopropyl chloride. The structure of isopropyl chloride is like this. Okay, I'm not doing H, I'm only mentioning the carbon and here you can balance it with H. Next you have isobutyl chloride. Okay, this is isobutyl chloride. N-propyl chloride. N-propyl chloride. Okay, this is also C, N-propyl chloride. And option D is N-butyl chloride. Okay, we have to find secondary halide. Secondary halide means what? Carbon which contains X, that should be attached to two other carbons, right? Then we will call it as a secondary halides, and here it should have H. Okay, so if I see the first one, okay, the carbon which contains the X, is it attached to two other carbons? Yes, it is attached to two other carbons. So yes, this is a secondary halide. Now let's talk about option B. The carbon which contains the halogen is attached to how many carbons directly? It is attached to only one carbon. So we will call it as primary. Now moving here, the carbon which contains the X is also attached to only one carbon. So this is also primary. Here the carbon which contains the X is attached to only one carbon directly. So this is also primary. So which is the secondary one here? Option number A is the secondary one. Okay. Moving to the next question. Are you ready for second question? Which of the following is not? This is very important to know whether it is asking yes or not. Okay. Not an allylic halides. Now let us quickly recapitulate what is an allylic halide. First pause the video, answer in the comment section, then see the video. Okay. So what is allylic halides? Allylic halides means you should have a C double bond C next to C. This C should have an X group attached to it. This is called as allylic halide, right? So if I see the options and I have to draw the structure. So let me draw the structure for option number A, 4-chloropent-2-ene, right? So I have this one. I have 1, 2, 3, 4. Okay, 4-chloropent-2-ene. Next, I have 3-chloro-2-methyl-but-1-ene. So first, let me draw but-1-ene, and then I have 3-chloro and 2-methyl. Okay, these are the structures. Now let's draw for C1, 1-chloro-but-2-ene. So you have, just a minute. Yes, I have 1-chloro-but-2-ene. So on the first one I have chlorine, and the option number D is 4-chloro-but-1-ene. Okay, 4-chloro-but-1-ene. So these are the structures given. Now let us analyze which of the following is a allylic one. Now if I see option number A, you can see here I have double bond these two carbons. The next carbon is containing the halogen. So can I see that this part is an allylic group? Yes, this is allylic. Option number B, here also you see this one. You have a double bond and then carbon and then chlorine, right? One carbon-carbon double bond, a single carbon and chlorine. So this is again a allylic group. Here can I see allylic group? Yes, you have this carbon, the next carbon is containing the halogen. So yes, this is also an allylic carbon. Now coming to here if you see, if this carbon would have contained an X group, then it would have been an allylic carbon. But here if you see, the carbon which contains the X group is not attached to a double bonded carbon, right? This is not attached to a double bonded carbon. So is this allylic? No, this is not allylic. All other options are allylic. So the question is asking which is not an allylic option. So that is your option number D, right? That is your option number D here. I hope this is clear. If this is clear, if you have answered it, please comment down. Please show your response in the comment section so that I will get to know that whatever I am teaching, whether my children are able to understand that or not. Okay, so that's all in this question. Let's move to the third question here. How many primary Rx or primary groups are possible for molecular formula C4H9X? Okay, this is very interesting question. We need to find how many primary Rx are possible. So C4 is there. So can I draw this as one? Yes, this is a primary group because this carbon which contains the X is attached to only one carbon. Okay, let's try one more structure like this. 1 second. Yes. this can have a X. Again, you can see the carbon which contains the X is attached to only one carbon. Now, can I have any other structure? If I draw like this, 4 carbons, right? C4. Yeah. So, if I draw X here, then is it a primary carbon? No. See, this carbon which contains the X is attached to 3 other carbons. So, this is tertiary. So, this is not possible. Can I draw anything like this? If you see here, this carbon which contains the X is attached to 2 other carbons. So, this is secondary. So, we need to find only primary one. So, I can have only 2 primary options. So, that is option number 2. If this question is also clear to all of you, please comment a yes or just let me know your answers in the comment section. Okay. Now, moving to the 4th question, classify the following compounds as primary, secondary or tertiary halides. Okay. So, first one is 1-bromo-but-2-ene. So, if I draw the structure, I have this one, 1-bromo-but-2-ene. Okay. So, the carbon which contains the X group, that is attached to how many carbon? The carbon which contains the X group is attached to only one carbon. So, this is my primary one, right? Next, 4-bromo-pent-2-ene. So, I will just erase this one and we will draw for option number B, that is 4-bromo-pent-2-ene. Okay. So, I have 5 carbons, 4 bromo, right? On the 4th carbon, you have bromine. Now, see, this carbon which contains the bromine group, that is attached to how many carbons? Here one carbon and here one carbon, right? So, the carbon which contains the bromine is attached to 2 other carbons. That means it is a secondary carbon, right? So, this is a secondary carbon. Now, let's talk about the 3rd option. What is my 3rd option given in the question? The 3rd option is 2-bromo-2-methyl-propane. So, 2-bromo-2-methyl-propane. Okay. Now, you see this carbon which contains the bromine group. This is the hero carbon. You have to check for this carbon. This is attached to 3 other carbons. That means this is a tertiary group. So, I can write here that this is tertiary. Primary, secondary and tertiary. So, 1 is primary, 2 is secondary and 3 is tertiary. So, that is option number D here. Okay. Fine. So, I think yes. So, we have been done with the 4 questions on the first topic, that is classification. So, if you have given all the 4 questions answer correctly, please give me a comment that ma'am, we have got 4 on 4. Okay. Just put a comment 4 out of 4 if you have answered all the 4 questions correctly. How much ever marks, if you have answered 2 correctly, just mention 2 out of 4, 3 out of 4, 1 out of 4, whatever you have secured. Okay. So, please put down this in the comment section quickly, and now we will be having more quiz coming ahead, and I want all of you to participate and comment in the answer section and answer in the comment section. Now, we will move to nomenclature. So, nomenclature here is not different. Whatever basic rules you have studied in class 11th, the same nomenclature rule is followed here, but for common names it is slightly different. You have to understand the common names properly, because in question common names are also asked. Okay. So, what is IUPAC name? What is common name? IUPAC name is the name which follows the rule, and based on the rules of the IUPAC convention we give a name. And what is common name? Common name is generally derived from the source of that compound. For example, cinnamon aldehyde, there is a compound like this which is obtained from the cinnamon plant, right? So, based on that source the common names generally arrive, or else there are different ways of giving common names based on the position and all, but generally this is not which follows the IUPAC rules and conventions, right? So, let's move to the nomenclature one. Okay. So, now just I want a very quick response from all of you, that nomenclature, okay, it is something which is sometimes becomes very easy, sometimes it becomes very, very difficult. So, do you enjoy nomenclature or you find it tough? Please put down in the comment section that whether nomenclature is easy for you or tough for you. Come and quickly comment it down. Okay, my children, bacha log, let's move to the next thing, that is structure, common name and IUPAC name. This is very, very, very important and you should be focusing here. So, basically, for example, I'll take the first compound here. Okay, if I draw the first compound, what is it? I have CH3, CH2, CH, Cl, CH3, right? What will be its IUPAC name? So we have, first we should write the substituent and then the parent name. So you can see I have 4 carbons here, right? 4 carbons, what is the word root? But. There is no double bond, it is a alkane, so suffix will be ANE, and then I have to write this 2-chloro. Okay, so that is the IUPAC name for this particular compound. Now here you can see that it is a 4-carbon butyl group, and this carbon is a secondary carbon, right? So you can write secondary butyl chloride also, secondary butyl chloride. Okay, similarly let's move to the next option, the next question or next example. You have like this CH3, 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 CH2, Br. Okay, now if you see this naming, if I want to do, I can just name it like 1, 2 and 3, okay, and then I have 2 dimethyl, right? Why? Because 2 methyls are there, and then I have 3 carbons, so it is be 1 propane, right? But I have to name this one also. This is present on the first carbon, so I have 1 bromo. Okay, alphabetical order you have to do. Now if you see here, this is having 5 carbons, and this particular structure is called as neopentyl bromide. Okay, common name is very important, neopentyl bromide. Next, if you see, I have just CH3 like this, and then I have Br, then you can name it as 1, if you just name 1, 2 and 3, right? So 2-bromo 2-methyl propane, or you can see 2-bromo 2-methyl propane, and the common name will be tertiary butyl bromide. Okay, next if I see this one, that's if you have directly double bond and then this one, okay, this is your if we call it chloroethene, okay, and the common name will be vinyl chloride. Next, if you see this one, what you will have, one in this case, okay, propene double bond is given more preference than halogens. So if this comes, numbering should start in such a way that the double bond should get the least number. Okay, please remember, double bond is having more priority than halogens. So I will name 1, 2 and 3. So I have 3 bromo prop 1 ene. Okay, I have 3 bromo prop ene. So when it is 1, you don't have to mention the position. Then you can see here this common name, this is an allylic group, so you can write simply allyl bromide. Okay, next coming to this one here, when you have groups like this, the halogen will be given more preference than the alkyl group. So you have 1-chloro 2-methyl benzene, or you can call it 2-chlorotoluene. Okay, clear? This is 1-chloro 2-methyl benzene. If you are naming it as toluene, that means you are giving 1 to this one, so it becomes 2-chlorotoluene. Okay, or simply you can say orthochlorotoluene. Okay, because this position is the adjacent one, which is called as ortho position, right? If you just know, remember this one, if I have like this, okay, this is toluene, this position is ortho, this position is meta, and this position is para. Similarly, this is ortho, this is meta. So I can just, if I'm naming this as toluene and chlorine is attached here, then I can say orthochlorotoluene. Okay, similarly, if here you see, this is you have the chlorine attached to the ring, attached to the carbon here, so you can name it as chlorophenyl methane. Means, just let me draw this for you. You have like this. Okay, so I have like this, to this carbon chlorine is attached, benzene is attached, right? So I can just write down 1-chloro, 1-phenyl and then methane. Okay, so basically when it is one position, you don't have to mention it, or you can just name it as benzyl chloride. Next you have CH2Cl2. So this is a very important name. You have CH2Cl2, you can name it as dichloromethane, and the common name is very important, methylene chloride. Okay, we'll talk about this particular name. It is very special, I'll tell you. CHCl3, trichloromethane or chloroform. CHBr3, tribromomethane or bromoform. You have CCl4, tetrachloromethane or carbon tetrachloride. Then you have CH3, CH2, CH2F. So you can say fluoro 1-fluoropropane or N-propyl fluoride. So when you have the rings, all the carbon in one chain, okay, if I have 3 carbons here, then it is called as N-propyl. If you have 4 carbons in one ring, in one chain, sorry, then you call it as N-butyl. Okay. Now moving to the next one, in dihalo compounds, this is again very important. Dihalo compounds having both the halogen atoms are further classified as geminal and vicinal dihalides. Okay, what do you mean by geminal dihalides? Geminal dihalides means one carbon is having both the halogen groups. Okay, 2 halogen groups are attached to one single carbon, like this you can see CH3 CHCl2. So this is a geminal dihalide. Okay, if we have 2 carbons attached on the 2 adjacent carbons, 2 halogens attached on 2 adjacent carbons, we call it as vicinal dihalides. Okay, vicinal means 2 carbons, 2 halogens. These 2 carbons should be consequent. Okay, they should be one after another. And so this is not called vicinal. So if I have like this, is this vicinal? No, this is not vicinal. You should have 2 consequent carbon or 2 adjacent carbons, halogen atom, then we will call it as vicinal dihalides. If one carbon is containing both the halogen groups, then we call it as geminal dihalides. Okay, so the common name here is very important. Here IUPAC name is easy, 1,1-dichloroethane. Here you have 1,2-dichloroethane. But when you have this one geminal dihalide, the common name becomes ethylidene. See, the spelling is very important. For geminal we have this word ethylidene chloride. Okay, ethylidene chloride, and here you have ethylene dichloride. Okay, ethylidene chloride is for geminal, ethylene dichloride is for vicinal. Okay, so please remember, this is very, very important, and it's also very confusing. Okay, please remember this one. If I have geminal, what is the name? Ethylidene chloride. If it's vicinal, ethylene dichloride. Okay. Okay, now again we'll come for quiz time, where we will be answering the questions based on nomenclature. Here also I have 4 questions, so please start answering by pausing the question. Okay, IUPAC name of the given compound. So what is the given compound here? I have CH3. Okay, then I have CH3, CH. I hope all of you know how to expand this one, CH2, and then Br. So from the alkyl groups, halogen is given more importance, so numbering should start from here. Okay, so I have 1-bromo 3-methyl butane. Okay, so 1-bromo 3-methyl butane, option number B is my correct answer, and I hope all of you have got the same answer. So you have to pause every question, answer it, and at the end you have to also give me your score. Okay, let's move to the next question. Common name of 2-chlorobutane. Common name is asked, 2-chlorobutane. Okay, so if you remember, I have told you this is secondary butyl chloride, which is option number C. Next, IUPAC name of C2H5, CH2C, Br, CH3, C2H5. So when it is C2H5, that means it is CH3, CH2. Next you have again CH2. Then you have CBr and CH3. Then you have CH2, CH3. Okay, so what will be the nomenclature here? 1, 2 and 3, 4, 5 and 6. Okay, so I have 3-bromo 3-methyl hexane. Can I get anything like that? 3-bromo 3-methyl hexane, right? Because first you have to name the substituents, and the substituents should be in the alphabetical order. So first will bromo, then will be methyl, and we have 6 carbon chains, so hex is the word root, and there is only single bond, so we have to use the suffix ane. So option number A here. Okay, Next I have, okay, here is this question. I have taken a screenshot from the book. Given the structure, you have to draw the structure of the name given. 1 bromo, 4 secondary butyl, 2 methyl benzene. Okay, so first of all let us draw benzene. Okay, next I have 1 bromo, so let this position be 1 where I am adding bromo. Then fourth position is secondary butyl, so 1, 2, 3 and 4. Here I will do secondary butyl. Next 2 methyl, here I have methyl. Okay, so you need to have bromine. Okay, to the next position of the bromine should be methyl. Here it is butyl group, so this is incorrect. Next, if you see the next one, here I have methyl. Okay, methyl and bromo are present. So see, if this is 1, okay, then which is the fourth position? This should be the fourth position, but here this is given in the third position, so this is also incorrect. Here if I see, if this is 1, this is 3, right? So I need to have methyl at the second position, so this is also incorrect. Here if I see, yes, 1 bromo, 2 methyl and 4 secondary butyl, so this is option number D is the correct answer here. Moving to the fifth question, the last question of this particular segment, you have to nomenclature this one. So I have a compound like this, CH3 whole 2. Okay, so I have like this, then I have CH, then I have C and then Cl, then I have C, CH3, CH3 and then CH3, then I have CH, just a minute, CH, I have CH3 and I have CH3. Okay, okay, now if I just want to name this, okay, so we have to find the longest carbon chain, and that too it should have the less like number of substituents. So if I number like this, 1, 2, 3, okay, 4 and then 5. Okay, so what is the substituents we are having? 2 and 4. Okay, on second and fourth carbon we are having substituents. What is other possible way? We should take that chain as the main chain where maximum number of substituents can be collected. So if I just consider this one, I can only have 2 substituents. Let me try it in a different way. So if I have 1, this is 2, this is 3, this is 4 and this is 5. If I see this chain, how many substituents I can have? I have 1 substituents, 2 and 3. I can cover 3 substituents here. Okay, but should I number in this way? So this is definitely the main chain that I can talk about, right? You can either do from this way or from this way. This is symmetrical. Now you tell me whether I should number from this side or this side. If I number from this side, I am having substituents at 2, 4 and 4 position. Okay, what if I number it from the opposite side? Just a minute, just see like this. If I number it like this, 1, 2, 3, 4 and 5. In this case, I have substituent on second and then fourth position, right? So if I total this one, this comes out to be 10 and this comes out to be 8. So definitely this is the lowest number, so this should be preferred. So I will be numbering it in this way. Now let's see what I have on the table. So we can have 2,2-dimethyl has to be present. So 1, 2, 3 and 4. So 2, 2, so on second position and on fourth position. So 2, 2, 4 trimethyl should be there. 2, 2, 4 trimethyl, 2, 4 dimethyl, 2, 4, 4, this is not there, this is also not there. So I have definitely got my answer here, from here only. But let's see further. 2, 2 trimethyl, then on the third one I have 2 propyl, right? 3, 2 propyl, then 3 chloro. On the third position also chloro is there. Pentane is there, 1, 2, 3, 4, 5, right? So on the third position I have propyl group, then I have 3, this propyl group is attached at the second carbon, and then I have chloropentane. So option number B is the correct answer. Just a minute. Now let's see the next one, that is nature of C-X bond. Okay, now here also, okay, just a minute, I forgot. So you have to now give me a score out of 5 nomenclature questions, how much you got it correct. Okay, so is it like 3 out of 5, 5 out of 5, 4 out of 5? Just put down your marks quickly. Okay, moving to the next section. This is very simple. Nature of the CX bond. What is this nature? So now you see, if I have this group, which is a halogen group, okay, so this halogen group is electronegative in nature. So what will happen? This bond contains some electrons, 2 electrons are present. These electrons will be attracted towards the chlorine side, right? And here there will be a delta negative charge, delta positive charge on the carbon, and we will have a delta negative charge on the chlorine atom. Now why this is happening? Because chlorine is more electronegative and it is pulling the electron towards itself. Okay, so you should understand that in this type of compound, this carbon is always electron deficient, whereas this chlorine or X is electron rich. Okay, now let's talk about the bond length here. If I have bond length, sorry, yeah. So you know, fluorine is the smallest atom here, so the bond length here is very small, means this, if this is F, the bond length will be 139. Now as you see, chlorine is a bigger atom, bond length increases. Bromine is further bigger, so bond length increases. Iodine is the biggest atom, so bond length is the highest here. Next we have CX bond enthalpy, CX bond enthalpy or the bond energy. So now if you see here, we have CH3F, this is a smaller molecule, right? So the bond length is small, that means bond strength will be more, means it is very difficult to break this bond. So we have bond enthalpy 452 here, highest one. Then we have 351, 293, 234. You don't have to remember the values, but you should be knowing the order. Okay, so next we have dipole moment. So dipole moment definitely depends upon the electronegativity. Okay, so but here you should be very careful that CH3Cl, okay, this atom or this compound has the highest dipole moment. Then we have CH3F, then we have CH3Br, and then lastly we have CH3I. That is because why you can attribute here, because fluorine is a very small atom, right? So it, although it is highly electronegative, but it cannot accept more electrons due to inter-electronic repulsions, right? The electron gain enthalpy of chlorine is more than that of the fluorine. So that is why chlorine will be more electronegative as compared to fluorine. Okay, chlorine will be more having dipole moment as compared to fluorine. Okay, electronegativity wise, fluorine is more electronegative. So this order, please remember, this is important. So now we'll do some very simple quizzes on this particular concept. Amongst the CX bond, the correct bond energy order is, this is again very important question. We have CCl bond, CBr bond, and I have CI bond. Okay, so now what is there here? If you see bond energy order, okay, you have to check the bond energy. So what is bond length order? Bond length order. So if I have bond length order, it will be iodine is having highest bond length, then you have bromine, and then you have chlorine. And bond strength order will be opposite to that one, right? So what will be the order of bond strength? You will have CCl, then CBr, and then Ci. Okay, Cl, Br, I. So we have, this is, which is option number A. Clear? Next, moving to this one, arrange the following bonds according to the bond length ascending order. Bond length order. Okay, so we have just discussed directly. So bond length of fluorine will be least because it is the smallest atom. Then we should have chlorine, then bromine, and then iodine. So that is why option number A here. Next, which of the following has the shortest CCl bond? Now you have to see this CCl bond is present, right? So this should have the shortest CCl bond, because of that means what, if I have an electron withdrawing group, okay, then the bond will be shortest. So you can see here the CCl bond depends on the extent of double bond character due to resonance or inductive effect. Greater the electron withdrawing nature of the group attached to the vinyl carbon, okay, this is the vinyl carbon. If that carbon has electron withdrawing group attached to it, then this bond will be very much shortest one. Okay, so once again I will repeat, this is the vinyl carbon, right? The group attached to the vinylic carbon, if this is electron withdrawing in nature, then what will happen? In that case, the bond will be shortest. Okay, so let's now see here. If I have this NO2 group is there, NO2 group is the one which is, see, first I'll talk here, there is no group attached. Okay, this one is an electron donating group by plus I effect. What is OCH3 group? OCH3 group is electron donating by plus R effect. NO2 is electron withdrawing group by minus R effect. Okay, so since it is electron withdrawing group, this group will have the strongest CCl bond. So answer for this question will be option number D here. Next, moving to the fourth one, in haloarenes, the CCl bond has a partial double bond character. This is due to, so if you see haloarenes, okay, the CCl bond has a partial double bond character. Why? Because of resonance here. Okay, so that is why option number C. So here I have 4 questions. Starting I was having 4 questions, and for nomenclature I was having 5 questions. So 5 plus 4, 9 plus 4, 13. So total 13 questions we did. You can just count down your scores and put down in the comment section. So now the lecture does not end here. We have something, next question also. Which of the following molecules has the highest dipole moment? This is very, very important question. Okay, highest dipole moment. Now let's see option number A. You have CH3 Cl. Okay, so what will happen here? The Cl group will be attached. Okay, so you can see that the dipole moment is always towards the more electronegative atom. So here what happens, you can see that all the dipole moments are pointing, this resultant will also point towards the top. All the dipole moments are pointing in one direction. Next, let's talk about option number B, CH2Cl2. So if I draw like this, so here I will have dipole moment in this direction, but this dipole moment will be in this direction. So there is a cancellation of dipole moment. You can see 3 of them are going in one direction, 1 is going in this direction. So there is a cancellation of dipole moment will decrease. Now if I talk about third one, CHCl3. So if you have Cl, Cl, Cl and H. Okay, so here you have dipole moment. Sorry, this one will be in this. So you can see these all 2 dipole moments are in opposite direction. These 2 are in opposite direction. So here also there is net cancellation. Then you have CCl4. Okay, so here the dipole moment are all in opposite directions. Okay, all the dipole moments are in opposite direction. So in that case, here also the net dipole moment will be different. So you can see only one option where all the dipole moments are in one direction. So this will have maximum dipole moment, and the answer will be option number A here. Okay, so total 14 questions now. So please answer them and put down your scores in the comment section. And now I'll have the best part, that is homework time. Okay, so I have given you 3 questions from 3 sections. This is your question number 1, this is question number 2, and yes, and we have question number 3. So please try this question and do not forget to comment the answers in the comment section. Then only I will know whether you have actually understood the concepts or not, right? So bacha log, everyone should be answering the questions in the comment section, and please give me a feedback. How was the class? Did you enjoy? Did you understand the concepts? Haloalkanes, Haloarenes part 1, if it is clear, please mention it in the comment section. Okay, this is very, very important for me to understand whether my students are understanding or not what I am teaching. Okay, so that's all in this video, students. I hope all of you have understood, enjoyed the class, and everyone will do the homework and put down in the comment section. So thank you everyone, and once again see you soon in the next class, and keep studying, keep smiling. Bye bye.